Hello and welcome to the last topic of Quadratics, which is the modeling with Quadratics. And we're going to use all of our skills that we've learned for solving Quadratics, drawing quadratic graphs, and knowing the delta, which is b squared minus 4ac, to solve real life problems. The example question, and it says a spear is thrown over level ground from the top of the tower. The height in meters of the spear above the ground after t seconds is modeled by the following function, which is h. Interpret the meaning of the constant term 12.25 in the model. Okay, first of all we need to know what is happening. So a spear is thrown over level ground from the top of a tower. So we have a tower, this is our ground, we have a tower, so here a spear is thrown over level ground from the top of a tower. So there is someone, like a stickman, throwing a spear. And if they throw it, the flow of it will be something like this. So the height in meters of the spear above the ground after t seconds is solved by the equation. So basically here we could model this as quadratic equation, because we have the highest point over here of where the spear is, and also when it hits the ground, that is going to be when the height is 0. So the h is the height and the t is the time. So for part A of the question, when we want to interpret the meaning of the constant term 12.25 in the model, it is basically when t equals 0, ht equals 12.25, because when we enter 0, then those two values disappear, and what happens is that we get a value of 12.25 meters, which is basically the height at which the spear is thrown. So it is the height of the tower. It is a height from which the spear is thrown. The height of tower at time t equals 0. And one more thing that I need to tell you is that t greater than or equal to 0 is a statement here, because the time cannot be less than 0. We cannot have negative time, therefore that's why in the question we have that t is greater than or equal to 0. Now for the part B. After how many seconds does the spear hit the ground? Now this will be basically when the height of the tower will be 0. So we have 0 meters over here, 12.25 meters over here. So basically when we have 0 meters, that's when we hit the ground. So what happens now is that if we make ht equal to 0, because height being 0 makes us know at what time we hit the ground. So 0 equals to, so now we solve this using quadratic formula. So A equals to minus 4.9, B equals to 14.7, and C equals to 12.525. Now this is T equals to negative 0.679 or T equals to positive 3.68. So 3.68 will be the correct answer because the time cannot be negative. So our conclusion for this is basically hits the ground, the spear hits the ground at 3.68 seconds. Now for the part C of the question, write ht in the form a minus b t minus c squared, where a and b and c are constants to be found. So basically, we have to complete a square. And we're going to complete the square by using the following formula. And this gets us the following. So now our values are a equals to 23.275, b is 4.9, and c is going to be 1.5. And in the D, using your answer to part C or otherwise, find the maximum height of the spear above the ground and the time at which this maximum height is reached. Okay, so basically that is when there is a turning point here. We can determine the time and the height of this point. And we do that by knowing that minus a and b give us the turning point. So that is 3/2 and 23.275. So one gives us the time and second gives us the height. So our conclusion will be the maximum height is at 1.5 seconds when the spear is at height to 23.275 meters. Now let's solve the exercise question. The diagram shows a section of a suspension bridge carrying a rod over water. The height of the cables above water level in meters can be modeled by the function hx equals to the following, where x is the displacement in meters from the center of the bridge. Interpret the meaning of the constant term 200 in the model. So our graph x and y and 0 here. So we got a graph somewhere here. It is not accurate at all, but it is 200 above the ground, as you can tell from the model. 200 is here. So we have our bridge over here. And I won't draw all of these lines, but basically our bridge is here. And we have our bridge over here and the water flowing here. So that's what's happening. And basically when the displacement in meters from the center of a bridge is 0, hx equals 200, the height of the bridge above water is 200 meters. And this is the height from from the center of a bridge, because we are 0 meters away from the center of the bridge. Now we're going to answer the part B, use the model to find the two values of x at which the height is 346 meters. So when the height is 346, then we have to find our value of x. So now we work this value out on a calculator, and x equals to 1103 plus minus 1103 meters. So when we have a height of 346 meters, which for example could be here, we have our distance from the center to be over a kilometer wide from both sides. Now, given that the towers at each end are 346 meters tall, use your answer to part B to calculate the length of the bridge to the nearest meter. So as we said, we have 346 meters height, and this appears to be our top, and going to the middle is 1103 distance, the same as here. So we just add those two together to give us 2206 meters, which is a 2-kilometer bridge. Now we got a question with the fertilizer company that uses a model to determine how much the amount of fertilizer is used in F kilograms per hectare affects the grain yield in G measured in tons per hectare. According to the model, how much grain would each hectare yield without fertilizer? So if we used a 0 fertilizer, and that is when F equals to 0, so when using no fertilizer, G equals to 6, the hectare will yield 6 tons. Now for part B. One farmer currently uses 20 kilograms of fertilizer per hectare. How much more fertilizer would he need to use to increase his grain yield by 1 ton per hectare? So, if F equals 20, because that is kilograms of fertilizer per hectare used, so when F equals 20, G equals 6.576 tons. So that's how much we grain yield in tons per hectare when we have the 20 kilograms of fertilizer used. And the question asks us how much more fertilizer would we need to increase his grain yield by 1 ton. Now he has 6.576 tons when the fertilizer used is 20 kilograms. So when we add 6.576 plus 1, then G equals to 7.576 tons. And so 7.756 equals to our model. And then we solve our quadratic equation. When we increase this by 1 ton, we get a very big answer of how many kilograms of fertilizer we're using for that 1 ton. And this one is unrealistic. And we have to keep with the bottom one because it is more realistic. So therefore we are going to use 59.6 minus 20, which is 39.6 more tons to increase the grain yield by 1 ton per hectare. And now that should be enough for you to go on to exercises at modeling with quadratics for exercise 2H.